Number 10. Asteroid impact. Although the circumstances surrounding the last mass extinction event are still being debated, the most likely culprit is a massive asteroid or comet, roughly 6 to 9 miles wide. Approximately 66 million years ago, it struck the Earth and in the aftermath claimed 3/4 of all life on the planet. Non-avian dinosaurs and many other species of plants and animals were completely wiped out. There are craters on our planet that suggest a long history of impact events. Outer space is basically a shooting gallery, and it's only a matter of time before a giant space rock will strike our planet again. In 2028, an asteroid that's approximately 1 mile wide will pass relatively close to the Earth at about 580,000 miles. It isn't considered a threat, but assuming it struck our planet, the effects would be devastating. Its impact energy would be over 1 million megatons, and it would level everything within several hundred miles of ground zero. A strike in the ocean would generate tsunamis hundreds of feet tall that would obliterate coastlines. Dust and debris ejected into the atmosphere would block out sunlight, and most life on Earth would perish. This is the likely scenario when the space rock is about a mile wide. The level of destruction increases depending on its proportions. An asteroid about 60 miles wide would result in total extinction of life on our planet. Number 9. Death by vacuum. Space is definitely apt at large-scale destruction, but it can also wreak havoc on anyone who risks exposure to the void. In 1971, 3 Soviet cosmonauts suffered a malfunction in their life support system in the form of a ruptured breathing ventilation valve. Georgy Dobrovolsky, Viktor Patsayev, and Vladislav Volkov are so far the only people to have been exposed to the vacuum of space. At the time, they were returning from a station and were a little over 100 miles above the Earth. They died within seconds of the rupture and are currently the only people to have lost their lives in space. Their capsule was automatically guided on re-entry. Recovery teams were shocked to find the crew dead, with blood dripping from their noses and ears, as well as dark blue splotches on their faces. In the absence of atmospheric pressure, space would inflict a gruesome death. Loss of consciousness would occur within 15 seconds, as the brain is deprived of oxygen. The last breath one takes would expand their lungs to the point that tissues rupture. The body would grossly swell up as water in the soft tissues starts to vaporize. The sudden drop in atmospheric pressure will essentially cause the liquids in the body to boil. Most of what's known about the effects of space vacuum comes from testing on animals. Based on the findings, one may survive for about 90 seconds without protection, provided they remember to exhale at the point of exposure. Number 8. Death of the Sun. Like all other stars in the universe, our Sun will one day die. It's a lengthy process that will commence with the star entering a red giant phase. This will happen several billion years from now, so we might not be around for it. The Sun is powered by a fusion reaction which converts hydrogen into helium within its core. Yet at one point, the core will be depleted and hydrogen will burn off from the shell around it. For a few billion years, the Sun will steadily increase in size and reach more than 2,700 times its current luminosity. The Earth's atmosphere will mostly disintegrate and the surface will become an ocean of lava with temperatures in excess of 3,860 degrees Fahrenheit. In the final stages of the Sun's expansion into a red giant, when it will be about 12 billion years old, it will likely vaporize Mercury, Venus, and the Earth. Even if the Sun doesn't swallow it, the orbit changes will likely send our planet on a collision course with the Moon. The Sun's expansion might also push the Earth out of orbit and send it drifting into the void of space to die as a rogue, frozen planet. There are other possible scenarios stemming from the death of the Sun, but none of them end in our planet's survival. Following the red stage, the Sun will eject its outer atmosphere and become a dense white dwarf star. This is a faint remnant of its former self, with no fusion taking place inside. It will eventually stop emitting light and heat as it decays into a black dwarf. Number 7. Black hole collision. Black holes are the mysterious regions of space that have sparked fascination both within the scientific community and the general public. They've been depicted as cosmic monsters, endlessly feasting on matter, but the reality is more complex. In their most basic sense, black holes represent the concentration of immense mass into a vanishingly small volume. Predictions in the framework of general relativity suggest that at its center, a black hole has a gravitational singularity, a region where space-time curves infinitely. The gravitational pull exerted is so strong that not even light can escape. The event horizon is the boundary past which no escape is possible. No one knows what happens past this point to whatever falls inside a black hole. The laws of physics as we know them, space, time, and the fabric of reality break down. If one were to fall into a black hole, the theory is that they'd begin to distort and stretch until the body snapped. It's been compared to toothpaste being squeezed out its tube. Even the atoms would become disconnected, stretching into a string towards the singularity. Stellar mass black holes are usually formed as the cores of massive stars collapse under gravity, generating explosions called supernovas. There are also supermassive black holes, which scientists believe rest at the center of all large galaxies, including the Milky Way. No one knows for sure how they are formed, but like all black holes, they absorb matter and increase in mass. In April of 2019, the Event Horizon Telescope captured, for the first time, a picture of a supermassive black hole. It's about 7 billion times the mass of our Sun and rests at the center of the galaxy Messier 87. Based on current research, the largest black hole discovered is called TON 618, and it has a mass equivalent to 66 billion suns. It's very distant, but assuming it collided with our planet, it would do so with an estimated energy of 500 septillion Hiroshima bombs. Supermassive black holes pose no immediate threat to us, as they're calmly churning away at the cores of galaxies. Wandering black holes exist in the universe, and one could pass through our solar system. The closest black hole is called V616 Monocerotis. It's about 3,300 light years away and 6.6 times bigger than our Sun. Should a black hole of similar proportions come within roughly 1 million miles of Earth, everything would be ripped to shreds. The side of the planet closest to the black hole will succumb to its relentless gravity and stretch out like spaghetti towards the event horizon. Number 6. Solar flare. Scientists believe that the Sun isn't massive enough to go supernova and potentially collapse into a black hole. As previously mentioned, it would likely enter a red giant phase billions of years from now. Yet even before that happens, the Sun has the potential to drastically modify the way we live. Magnetic explosions on the Sun's surface translate into solar flares, which are sudden flashes of increased brightness. A common misrepresentation is that they'll engulf our planet in a raging blaze. What actually happens with large flares is that clouds of charged particles, known as coronal mass ejections, may hit the Earth's magnetosphere. From our planet, the light show would be spectacular, with bright auroras covering the sky. However, the ensuing geomagnetic storms will likely knock out satellites and electrical grids. Anything from cell phones to airplanes would essentially be decommissioned. The last major solar flare to hit our planet occurred in 1859. It became known as the Carrington event, named after Richard Carrington, the amateur astronomer who observed it. At the time, it disrupted telegraph communication. Considering our current reliance on technology, the effects of a similar flare, or one that's larger, would be devastating. Number 5. Living in space. So far, we've mainly contemplated a number of large-scale disastrous occurrences, but the scenario needn't be so drastic. In the future, humanity might need or want to relocate to outer space. By that time, however, there are a few key issues to work out. There's harmful radiation that would bombard those living in space, unless exploration agencies find better ways to shield them. For example, astronauts making an interplanetary trip to Mars would likely expose themselves to the equivalent of a full-body CT scan every week. If they don't succumb to radiation sickness, the likelihood of developing cancer is really high. Life in space would wreak havoc on our immune systems as well. It seems that living in microgravity tampers with the activation of cells responsible for fighting infections. Researchers have compared the severity of the matter to a person having an HIV infection. Extended stay in microgravity also causes a person to suffer from the significant loss of bone and muscle mass. Bone may seem rigid, but it's actually living tissue. It's still unknown why, but microgravity causes it to break down at a much faster rate than it's built up. It can get so bad that people would have a lot of trouble readjusting to Earth's gravity should they want to return to their home planet. Number 4. Rogue planet collision. Even though the full size of the universe is incalculable in proportion, the 93 billion light years that we can observe don't describe a static or uneventful environment. It's a dynamic place, full of movement, transformation, and remarkable occurrences. As previously mentioned, some of these events can have devastating implications for life on Earth. Our planet could one day be struck by a rogue planet, a cosmic object that doesn't orbit any star but rather the galactic center directly. It's currently believed that the Milky Way has billions of rogue planets. It's possible that one of them will, at one point, collide with the Earth. According to a theory commonly known as the Big Splash, the Moon was formed after the early Earth collided with a planetoid the size of Mars, also known as the Giant Impact Hypothesis. It states that approximately 4.5 billion years ago, the direct hit caused a mixing of the planetoid and the proto-Earth. It's currently the favored scientific theory regarding the Moon's formation. Should a rogue planet start hurling towards the Earth, it could destabilize our planet enough to knock it out of orbit. The Earth could end up on a collision course with nearby Venus or Mercury, or simply wander off into deep space, becoming a rogue planet itself. A direct hit would send debris flying across the solar system and melt the planet along with all life on it. Number 3. Space trash. Much like here on Earth, trash in space is a problem of our own design. In the early days of exploration, due to the sheer immensity of outer space, agencies weren't concerned with what they were leaving in orbit. Whether these were discarded components from stations, rockets, or satellites, many wouldn't give space trash a second thought. At the dawn of a new age for space exploration, the concern seems to have taken root. Engineers are discussing the KESSLER syndrome, which is, by all accounts, a horrifying scenario. It entails the launching of so much material in orbit that there's simply no more room for more. Random collision, objects hurling towards the Earth, and many more problems may arise in consequence. Tighter laws on space littering might, in the future, help avert such disasters.
Before we move on, official They Will Kill You merchandise is now available at theywillkillyou.com. It's out of this world.
Number 2. Gamma ray burst. A gamma ray burst, or GBR, is the brightest event known to occur in the universe and is typically caused by a supernova, the explosion at the death of high-mass stars. These bursts release potent radiation that may one day threaten life on Earth. A likely GBR candidate is a star about 8,000 light-years away. As it goes supernova at some point within an estimated 500,000 years, the gamma-ray jet may strike the Earth. It would fry the ozone layer and leave the planet exposed to the full force of the sun's radiation. Mass extinction is a likely occurrence and possibly a case of history repeating itself. The ORDOVICIAN-SILURIAN extinction event, which occurred on our planet 455 to 430 million years ago, may have been caused by a 10-second GBR. The source of it was potentially a hypernova within 6,000 light-years of our planet. Marine life was predominant at that point, and about 85% of species were wiped out as they were exposed to extreme ultraviolet radiation. Pointed directly at Earth, a gamma ray burst in the Milky Way could yield unprecedented destruction or, at the very least, force us to find a radical new approach to life on the planet. Number 1. Death of the universe. Should humans make colossal scientific leaps and survive way into the future, it's conceivable that we might one day witness the death of the universe as we know it. Based on our current scientific understanding, human death and the end of the universe are relatively different concepts. From a strictly biological perspective, not accounting for spirituality, we perceive our mortality as the end of our life, of our time on Earth. The death of the universe, however, would essentially be a point in which time itself is meaningless. Entropy, the amount of deconstruction able to take place, cannot increase. Basically, nothing happens anymore and nothing ever will. Dark energy, a type of energy that science has yet to understand, is believed to be responsible for the accelerated expansion of the universe. It may account for almost 70% of all energy in the observable cosmos. Should dark energy keep pushing outward with growing density, it will eventually dominate all other forces in the universe. This hypothetical form, known as phantom energy, will tear apart solar systems, galaxies, and, ultimately, even atoms themselves. The theoretical event is referred to as the Big Rip, a scenario in which the universe ends in singularity, with the density and expansion rate of dark energy becoming infinite. It would be a cold and lonely place, somewhat similar to what would happen in the Big Freeze. This is another prominent theory stating that all the stars will eventually die out and that the gas needed for the formation of new ones will become exhausted. Black holes will take over and, in time, start to cannibalize each other. They too will ultimately shrink and evaporate, unable to gain more mass. Some, however, believe in a symmetrical model of the universe and predict its demise based on it. At the birth of the cosmos, the Big Bang was an explosive expansion of matter. The Big Crunch would mean that the universe would cease to expand and contract under its density to the condition before its birth. This gives way to a cyclic model, with one universe dying in a Big Crunch and the next one being born in a Big Bang. In its most basic sense, the battle for the fate of the universe is between dark matter interacting with gravity and keeping everything together, and dark energy ever expanding and trying to pull everything apart. All current predictions for the death of the universe are a matter of speculation over the span of trillions upon trillions of years. It's inconceivable at the moment what existential form we'd need to achieve in order to still be here across such a monumental event. There's also a theory of multiverses that can be created or that are already in states of existence. This would urge a new understanding of space-time that may also account for the ultimate survival of our species. Should we grasp the mechanics of multiverses, we might one day be able to observe the death of this universe from one that's still in its infancy. Thanks for watching. If you weren't bound by space and time, which cosmic event would you rather witness? The birth of the universe or the inside of a black hole? Let us know in the comments section below.